Hey everyone, welcome back to the next tutorial in the Python Tic-Tac-Toe project. Before we continue on, last time if you have been following so far, we have defined what the minimax function is. And we just need to make a couple of changes in here. And a little mistake that I made last time was actually apparently I didn't change this. So this needs to be best y equals current j. And what else you need to do is it shows this warning of sorts that local variable might be referenced before assignment. That's because it's not entirely sure if this variable might or might not get defined at any point. So if you're worried about that, you can just remove this condition from here, and you can just say else, because if we know the player is not computer, it's going to be human. So there's not really anything much here. And what I forgot to do the last time was actually return something from this function, return score. So you'll need to add that as well. Sorry for that. And with that, we have completed our minimax function. So time to go back to our computer turn and actually make it smarter here. So let's get rid of this. And what we can actually do is say if get depth is 0, this pretty much stays the same, but what I suggest is instead of calling it every time, what you can do is just call it once, and we can store it in a variable. That way, because this value will be used plenty from now on. So next, what we'll be doing is we'll be checking if depth value is 0, or if someone has 1, either the human or the computer, the comp. Then we will just return, and then what we can do is we can just add a print statement that says hey, and it's just a little thing for the human seeing this. It is the computer. I am gonna have to escape that. Computer's turn, so that at least our player knows what's happening. So, and then we check again that if the depth is equal to 9, that means the computer got to go first. So we'll take this off and we'll just put it over here, so that if it's the first one, we won't waste our time and resources by calling minimax just for the first one. Just the computer can put at any random place. That way it actually gets a personality. Look at there, we're already making a robot. Okay, so if it's not 9, that means it's some other number. It's somewhere in the middle, i.e. it's not at the starting of the game. So we'll just give it an ij, and we don't care about the third value, we don't care about the score, and we'll call our minimax. We'll pass in the board, we'll pass in the depth, and we'll pass the comp, because at the top level we want what's best for the computer, so that's what goes in. And then we will just say if the board is I and j, if the board's I and j value are 0, then we can just say that the board I and the board j is equal to comp. That means as long as the computer chooses a legal value, and if it doesn't, then you just return. That won't happen anyway, so but just as a failsafe. And what you can say is that the print, you don't need to print anything for now, so let's just go with show board, and we'll give it a board, we'll give it the player key, and we'll give it the computer key as well. And that pretty much does it, I guess. Let's take a look at the main function. Main function looks fine as well. So what we actually need to do here is add another line here that can just say, like what's actually going on, that says print as a rule x always goes first. I mean, that's in the actual rules of tic-tac-toe. I looked it up. Yeah, I don't know why I did that, but you get the point. So let's try running this now. So hopefully our computer is smart by now and it is ready to beat us. So it asks what would you like to be. Let's go ahead with X. So it says you have taken X, computer gets the O. As a rule, X always goes first. And it asks me enter its cell number. And if let's say if I enter 3 and my X comes over here, and then immediately the computer takes it. Oh, and why is it saying computer chose wrong and forfeited its chance? It's not supposed to say that. Hold on. If the board is this, why else would the computer print this? I don't get that. Hold on. We don't we don't need this now. This is happening twice because we wrote this the last time since our computer was dumb back then. We don't need that right now. Our computer is pretty smart right now. So let me just rerun that, and yeah, everything should be good now. So let me just take the middle value 5 and I choose there, and okay, the computer chose at 1, so I'll go with 3. And whoa, it knew I was gonna go for a 7, so it tries making an O here. Good move. I will try to play a 4 to stop it, of course. And it again stopped me from winning by playing at 6, so you can see that this is actually a pretty smart one. I play at 8, it goes at 9, and that's the last place left. I mean, it went at 2, and now I go at 9, and that's just it. The game's over. So at this point, it seems that the game is going pretty fast, and you need to actually go back up to see what's happening. One thing what you can do to reduce is what I did in my actual version of the tic-tac-toe as well, is import time. And what you can do is you can place this time at multiple different places across the game, especially places where during the computer turn and during the player turn, so that our whole computer turn doesn't get executed at once. I mean, the whole computer play just gets executed at once and you don't get to understand what's happening, and before you can understand, that's it. So what you can do is, let's just say after this time, it sleeps for, let's say, about 1.5 seconds. Now, these times are arbitrary, what I'm doing here. So it's totally up to you what you do with the times and everything. And like, just fine-tune the timings to what you like and how you feel, like what's the actual proper time. And then once the player has chosen, you can time.sleep a second here as well. And even in main, what you can do is, hold on, my bad. Even in main, when the player's turn gets done with, or starting here, you can say print, not print, time.sleep for, say, 0.5. Again, this is arbitrary. You can choose and play around with time, see how it sees fit for you. Time.sleep 0.8, and just putting random numbers at this point. Time 0.8 and something. You get the idea. So now, one of the main things that I talked to you about is the things that I made in my final version is having colors in your board. So that way you actually have a sense of where did the computer play and where did you play, what are this and that and this and that. It actually helps a lot. So there's only one place where you need to add colors, and that is in the show board. Exactly here. So I'm not actually going to be, I don't think I should actually explain this. If you do a quick Google search about using colored text, I think that was the thing I searched up, using colored text in Python CLI or different things like that, you will get a lot different color options, lots and lots of different color options. But these are, again, the colors that I chose. Now, I'm not going to type them out. They're pretty freakish to type it out. Otherwise, I'll leave a link in the description below from where I found those colors. And for now, I will just copy paste a couple of values from there. Oh, hold on, let me find them first. Yeah, these are the values, and this is when the board is for the player. I'll just copy this and I'll paste it here. Pretty much the same thing. The only thing that I'm doing is that I'm wrapping it in a formatted string with these values, such as \003, right square bracket 91M, which is wrapped inside the value, and the same thing. So what that does is it prints it in the color value so that it actually looks kind of good to us. Again, I've chosen just a few values over here. You can play around with the color values as well, so that you get your own look in the whole thing, so that it feels much more unique to you. And yeah, I pretty sure I should have done this beforehand. I should not be doing this on camera, but you get the point. So, if we okay, so we have that done. So if we now run this should look a bit better. This time let's go with O. So as you can see, the computer waits a bit. Oh wait, we need more lines. Hold on. So we need more lines. Let's just increase these lines. Yep, that should be better. And we should not see the showboard 2 times. Like, we should only see the showboard once. So let me just get rid of this showboard from hold on, wait. Oh, okay, this is the first showboard. Then let's just keep it for now. So this should be our final app by this time. So let's go with O. And it says you have taken O, computer gets the S. As a rule, X always goes first. It shows us the board first, and it says, hey, it's computer's turn, and the computer chooses X. And it takes X. And as you can see, this space is getting smaller now, because previously, instead of hold on, where is it? Instead of using 16 here, I use 10. So again, you can play around with this value and see however it sees better for you, or whichever you feel like. You can totally go ahead with that. But this, yeah, you should probably change this to maybe 10, or let's just keep it like that and let's just go with the game for now. I'll go with 3. Mine comes in a different color, and then the computer plays here. It's about to win. I'll try to stop it. I play a 7. It gets here, and then it says 2. Let's go with 2. I try to stop it, and it just says game over. Why? Oh, because the computer won. Damn it. I need to correct this. I need to correct this a lot. So let's just put this center of, I don't know, 10. Okay, let's just keep it at 10. And well, you can, at this point, you can pretty much play around with the app on your own. Oh yeah, and there's one more thing that I forgot to mention that I told you I would tell you, is showing how many possibilities did your app actually search. So for that, what you need to do is just declare a variable, recur call. You can call it anything you want. I'm just calling it recursive call, and that recursive call is initially set to 0. And what happens is you can go back to your minimax, and inside your minimax you need to call this value. But every time this is called, the value should not be changed. So what you need to do is use global recall. That means it will access the value of the variable that was defined globally and not a local variable. And you just call it again and increment its value. That's it. You increment its value every time you call minimax. That way it kind of tells you how many times you actually ended up calling it. But what you also need to keep in mind is returning that recur call value back to something again. Otherwise, it would just keep, adding and adding and adding. And like from the first search it had for the first turn, let's say it searched for 6,000 possibilities, and at the next turn it searched for 2,000, then at the final it would show you 8,000 instead of showing that, hey, I just searched 2,000. So what you need to do is again reference global recall inside your computer turn, and once you show your board, you can just have a print statement that says the computer. Hold on. Searched. Nah, let's just go with this. Let's just put recall call here and possibilities. Hold on, possibilities. Yeah. Python will add the spaces for us. And once you've done that, you can set recall call back to 0. So that way it just, gets ready for the next possibility. So again, I haven't fixed the size issues yet. You can again play around depending on how big or small you want the tic-tac-toe to be. So I go with X, the computer gets the O, and I can enter a cell number, and let's say I enter 2. It says, wait, hey, it's the computer's turn, and the computer searched 63,905 possibilities, and whoa, this is way too much. I need to fix this ASAP. This is way too distracting to play in any way. This is center 10, so let's just keep it as center 16, and let's just keep the number as center 16 as well. Again, you need to play around with the values, like what your font size is and what font you're using. It all depends on, it comes down to that. So let's just give it X here. Come on. Okay, now it goes way too far. Great, that's great. I play 6 and it stays pretty much there. Hold on, I just need to increase these a lot now. God, I'm so bad at this. But hey, that's how you learn, right? You make mistakes and you keep on learning again. So now we have X, O, and yeah, looks decent now. Let's give it 6. So we get our X here, and the computer searches 63,905 possibilities and chooses this 3. Let's go with 5. The computer knows we are trying to make a row, so it'll of course make one here. Again, you can see there's a lot of issues going on here. So we can just work out the values for you and how it's working for you, because I obviously in my own file I made and wrote it in an entirely different way, and it might not work with this exact same code in yours. So be sure to keep that in mind when you're actually working on yours. And I guess that's it. With that, we come to an end of the Tic-Tac-Toe project tutorial. So let me know how you guys liked it and what other projects you'd like me to do in the future. And of course, I'll be leaving the GitHub repo link for the entire project in my description, so you guys can follow up on the code, make some changes and everything if you like. Let me know if you have any great modifications for this code, because obviously I created this a long time ago. I just thought it would be a good experiment to show. And that's pretty much it. So I'll see you guys next time.